Question 12 is an integration question. I was a little bit limited in what I could give you here because I said it was only up to exercise 11C or section 11.3. This is in fact two questions out of exercise 11C. So if you'd actually done those textbook exercises, you should have been able to do these questions. A little bit harsh of me perhaps, but that's what I did. So we're trying to integrate 1 over kx between these two limits, and we've got to work out what k is. The reason they ask the questions like this is to stop you just cheating and doing it on your calculator. They're asking you the question backwards. There are actually two ways of integrating 1 over kx. One is to take the constant outside, okay, like that. And then the answer is going to be 1 over k times the natural log of mod x, and then of course plus c. The other way of doing it, you don't need to do both, is just to treat it as kind of chain rule backwards. So treat this as, you know, one thing, if you like, and say this is going to be natural log of kx, but by chain rule backwards, you have to divide by 1 over k. And you may think to yourself reasonably that how can it be two different answers? Well, the answer is it's not two different answers because this log would split into this log would split into log of k plus log of x, and then this constant plus that constant combines just to make a new constant. So they only differ by a slightly different value of c. So actually they are equivalent. So you can use either of those. I don't really want that in there, so I'm going to rub that out. And I don't really want both of the. I'll only use one of these anyway. So I think I will use, which one shall I use? I'll use this one. So therefore, the integral from e squared to e to the power 8 of 1 over kx dx is 1 over k times the natural log. I'm going to use this one, why not? Between e squared and e. Actually, it's easier if you use the other one, isn't it? Never mind, I've done this one now. So that is 1 over k. I'm going to take that outside because it's not affected. And that is going to be the natural log of k e to the 8 minus the natural log of k e squared. It would have been a lot easier to use the other one. So that is 1 over k. Now, I do have to split the logs up here, right? So I've got ln of k plus ln of e to the 8, which is 8, which is just 8. Well, ln of e to the 8 minus ln of k minus ln of e squared. Okay, so the ln of k's cancel out, which is why I didn't really need them in the first place. And then I've got ln of e to the 8, so it's 1 over k. Ln of e to the 8 is just 8. Ln of e to the 2 is 2. So that is 6 over k. So that is my answer to that one. And the second part is this trig. Oh, sorry, I haven't answered the question yet. I've got to solve that. Always a good idea to read the question. So that was correct, what I just rubbed out there. So 6 over k, but this is equal to 1/8. So therefore k times by k times by, so k is 6 times 8, which is 48. And that is the answer. Always check the question. Right, question B is also taken out of exercise 11C. So we are being asked to expand sine of 5x plus 2x and 5x minus 2x. So sine 5x plus 2x is sine 5x. These formulae are in the formula book if you don't know them. plus cos 5x sine 2x, and sine of 5x minus 2x is sine 5x cos 2x minus cos 5x sine 2x. I'm going to call that equation 1, call that equation 2. And what we actually want is to add this. We want the 7x plus the 3x. So we want to add those two equations because this is obviously 7x. So therefore 1 plus 2 gives us sine of 7x plus sine of 3x is equal to twice sine 5x cos 2x, because those terms cancel out. Okay, so that's all you had to do there. And then, well, believe it or not, that was 4 marks for that. And then hence integrate sine 5x cos 2x. Okay, so that was part 1. And then for part 2, we want to integrate sine 5x cos 2x. Well, that is half of this thing, isn't it? So that is half of the integral of sine 7x plus sine 3x dx. Sine 3x integrates, so it's a half of minus cos 7x over 7 minus cos 3x over 3 plus c, which is minus a 14th of cos 7x minus a 6th cos 3x plus c. Is that all we had to do? Yeah, that's all we had to do. 3 marks. That is my answer. And that, I believe, is the end of question 12. That method, by the way, does come up. You're in A-level papers, you are sometimes asked to do that. And it's a recognized method for integration where you need to integrate, for example, a sine times by a cos, and they're different multiple angles. You can also do sine sine or cos cos by using the formulae for cosine.